liked it, skipped it. AI trends that we were meant to research this year, or last year. I do work for VGW, but today everything I present will be my own personal views and opinions. That's it. It's very easy to feel overwhelmed, exhausted, and quite frankly cynical with the avalanche of information that comes to us in AI field. I certainly feel like that. Today, let's hit the pause button and look back at 3 important sections. Let's talk about the best large language model. Yes, that one. Let's talk about visual large language models, and let's talk about agents. So what I hope to achieve by the end of this presentation is a technique called knowledge distillation. So I want to give you my intuition on what is important, what is worth looking out for, how to filter a signal from the noise. And first, let's jump into the best large language model. I forgot to update. I'm so sorry. That's a joke. Of course, you know that a new model comes out every 2 weeks, beating all other models on some sort of benchmark. And while there is skepticism on benchmarks in the AI community, one thing is clear. They do get saturated very, very quickly. This is American Introductory Mathematical Examination. Exam in the US, which only 2% of high school students are invited to sit. Very challenging mathematical questions. And you see, in the last 2 years, models went from unable to solve a single question to doing 93% with the most successful model. How about non-verifiable domains? Not math, where there is an answer. Not coding, where there is a criteria of code compiling and running. How about non-factual domains, like conversations, some more creative domains? For that, there is a chatbot arena, or lmarena.ai. It's where you can ask questions to 2 models anonymously and then vote for whichever you prefer. So here I'm asking 2 LLMs my favorite trick question to large language models. I went online, found famous person, then Googled their mother's name, and here I'm asking, who was the son of Elizabeth Ballman? And on the right it says, I'm unable to know, on the left it hallucinated something. Then, in the same context window, without refreshing, I'm asking it, who was the mother of Karl Lagerfeld? And boom, it tells me it was Elizabeth Ballman. So you do know the connection, right? Why didn't you tell me this? And this highlights a peculiarity in how large language models store, represent information, which is called reversal curse. In this monstrosity of parameters that has distilled all human knowledge to a couple of 100 billion floating points, digits, there is everything that we know. There's the theory of relativity, there are all the memes and jokes from Reddit. But it's not a relational database. It's not a bidirectional graph. What is it? How does it retrieve information? It's a very interesting and hot area of research. You will be hard-pressed to find a non-proprietary model in the top of the leaderboard on LM Arena. The best non-proprietary open-weight model is DeepSeek R1. So let's talk about that model. Why is it notable? Forgive me, I started preparing this topic in February when DeepSeek was all the talk of the town. Remember how it crushed NVIDIA shares? They recovered, they crashed again. So why is it notable? To me, they did lots of clever tricks, but to me, the most interesting thing comes from here. Quick detour into the training process for large language models. There is pre-training, there is post-training, and there is alignment training. In the last few years, most of advances and improvements came from pre-training. The output of pre-training is the autocomplete, the token tumbler. And engineers at the companies that are training these big foundational models, they knew that if they put more data for training, more parameters, more compute, they'll get almost predictable, almost linear improvement. But as Ilya Sutskever, one of the co-founders of OpenAI, said in his recent keynote speech, the age of pre-training is over. We have but one internet. So there's a data wall. There's no more good quality training data available. So many people in the industry believe that all the advances will come from the post-training. And post-training is where model takes on its personality. It is very resource intensive. It requires huge corpus of data of high quality conversation. This is where LLM takes on its personality, as I said, like Grok becomes a bit cheeky and more open. Some other LLMs become different personality. So what DeepSeek has done, among other clever things, they hacked this part and they introduced reinforcement learning. So instead of creating a huge data set of high quality questions and answers, they try to let model figure out what's the best way to get to the answer. And many people are very bullish on reinforcement learning, and you probably watched that movie on Netflix about AlphaGo. This is the first public success of reinforcement learning when Google's AlphaGo has beat Lee Sedol, the master of Go, game of Go. After enough training, it started to exhibit superhuman abilities, and it made a move that was coined Move 37. At the time, it seemed very confusing, very bizarre, but it allowed the AlphaGo to win the game and become world championship. So the question is, what will be the Move 37 for LLMs if you allow them to gain the power of reinforcement learning? DeepSeek developers believe that they've already seen something like that. In their paper, they identified this aha moment. The model, similar to human reasoning, is able to mark something significant, like a light bulb moment that will allow it to get to the right answer quicker. Right, let's move on to multimodality. Just like you and I perceive this world through audio and images, we expect our models to do the same. That's why visual language models have come to prominence in the recent years. And I love looking at benchmarks to see what are models even expected to do this day and age. So this is from one benchmark called Vista benchmark. It is 60% solved, so it's not completely solved, but the models are getting there. And the questions that are asked are really tricky. The visual language models are expected to look at the image and reason about it. For example, on the right, it's asking, is this couple selling or buying a house? And what's the price? So a model is required to evaluate the surroundings, figure out like where is it, what country, how much the house should be cost. And then one of the correctness rubric is model will not hallucinate because it's impossible to figure out are they selling or buying from the given information. On the other image, another tricky question asks how many people and cans of paint will the scaffolding above support? And model is expected to answer none because it's not safe enough. So you see the level of reasoning that is expected from VLMs. Okay, of course, seeing this technology, you want to get your hands on it. And I have two ways for you. Public, if you don't mind, if it's an image that is not very private to you, I think the best way to go on lmarena.ai. And no registration, no API keys, everything is free. Just pick one of the 94 models that they give you for free, feed it your image, and ask any questions you want. Select your favorite one, and then think how to get API key or whatever. Or if it is something more private, you can download client from alama.com, you can pull one of the supported vision models, you run it in your terminal, and you just simply analyze the image. So I decided to give it a go. I don't know about your laptops, my laptop is infested with my personal data. I have photos downloaded from daycare, from here, from there. I thought it's about time I take control of that. So I just fed it a random photo, and I asked it to describe what it sees. By the way, it's all done on Apple M1 Pro, and this is the GPU diagram. You can see it's spiking, but it's nothing that it can't handle. And it did pretty well identifying the ocean, the children, two of them, and kind of capturing the mood of this photo and correctly saying that it is a family photo. So then I took this bare bone functionality and I turned it into a Python project that goes through all my images and reasons about them and then sticks them into appropriate folders. It did pretty well, I must say, in my family photos, all kids and all that. Interestingly, I'm not making this up, but the only professional photo I have stored, it was not able to identify it as a family photo. And Yeah, I think even AI, when sees professionally done photo, recognize it. Okay, OCR, let's talk about optical character recognition. I first came across this cool functionality when I was helping a friend of a family find trace of long-forgotten family connection person. This is a scan of a newspaper from 1924. And it is so defective, it's really hard to figure out what's happening in the end. The most interesting part, what has happened to him in the end. So I just fed the entire PDF of the newspaper and screenshots of the most faded away parts to OpenAI. And it did very well. I mean, it's almost a magic. Like, I would never have figured out that there is something like Cossack officer written there, but it makes sense. So this is an example where hallucinations are useful. It took the context of the whole newspaper article and then slightly hallucinated something. A couple of words are probably wrong there, but altogether it makes sense. How about applications when almost right is catastrophically wrong? Like you need to get reading from a mirror. In this case, I was running some evaluations just on a single image, and it was getting me all sorts of readings. Like, you pick your favorite. So at first I was very confused, like, this is rubbish, and this is not even usable. Then I learned that I need to reduce my temperature right down to 0, and at least it will get you consistently wrong outputs. And then from that, you need to think what to do next. Because I was relying on zero shot, I went and searched for a better model. It's still not perfect. And the next thing to do is parameter efficient fine-tuning. But for that, you'll need some training data. And I didn't feel comfortable walking around taking photos of my neighbors' water meters. But if you see me doing that, it's for science. When you see something like that, naturally you're very curious, how does it work? How is it evaluating and reasoning about images so well? What's going on? Is it like a router that ChatGPT sends images here and text there? And if so, can I just cut out the visual part and use it in my project, or do I need the whole shebang? So it turns out you need the whole shebang. So how it works, we already learned from Tyler's presentation this morning all about embeddings. So image is getting encoded by a visual transformer, and image becomes a dot in this multidimensional space. Then text is also encoded into embedding. And then this critical part, the adapter in blue, is what we need to, we, some other smart people, what they need to train to put these two dots next to each other. So when you're feeding it an image of a deer, it looks around and finds embedding, textual embedding that says deer, and more complex scenarios. All right, let's talk about agents. Everyone talks about agents like they're done deal, like everyone knows what agent is. I don't. I sourced some big names in AI and what they say what agent is, and nobody agrees with each other. There's so many definitions. So from reading that, it sounds like an agent is something that I see Ollie's taking photo. Agent is something that is using LLM and tools and interacts with environment, but it's really vague. I actually like different definition from a developer. I watched a video from a developer who actually works on agents for a big bank in Russia, and he came up with his own idea of, instead of binary classification, agent, non-agent, it will be measure of how agentic something is. Does your application use tools and writes tools when it needs it? Mark it high. Doesn't use tools or use, like, I don't know, weather API and calculator? Mark it low. Reasoning, does it go through internal chain of thought process, or does it spit out the answer straight away? Mark high or low. And finally, autonomy. How much interaction from human overlords does it require? Okay, so I was curious to try it, so I again followed the same developer I mentioned earlier, Konstantin Raskin, and I followed his demo, and I created an agent system. So let's have a look. So you set a topic, and you set number of messages that you want to know, you want to look at. Then there are two agents that will take on certain personalities, and they will debate about given topic forever. Nobody will ever win, but it's very entertaining to watch. All right, and this is built with LangChain and LangGraph, and these two technologies, they're the most popular today for building agents and multi-agent system, and they come with pretty sick debugging tools. It's hard to see here, but in LangChain Studio, you can see a graph of states firing up in real time, and you can breakpoint, you can pause it, you can see what's happening, and how the state is preserved between two agents. So how does it work? Did I tell it what Elon thinks? Did I tell it what Sam thinks about AI? No, I didn't, because it takes advantage of LLM. LLM is smart enough it knows enough about those people to come up with the content. All I had to do is I have to describe the graph. There's a global state of a graph which is passed on between the agents. So think about this, think about chatbot support multi-agent system. You won't have to repeat your problem every time you go into a new department. Maybe that's the future. Then you define a role. Then you initialize those roles with whoever want them to be, Elon and Sam in this case. You set up a template. In this case, there's only one little hack there saying don't rush to reveal all your thoughts. You'll have time, so the discussion flows a bit better. And finally, you build the graph. And then that's it. This is a very trivial example, as I said, but I think it is fun to look at the multi-agent systems here and how LangChain and LangGraph can help you to build it. By the way, yesterday in AWS Game Day, I had a look in our little quiz with agents. It was all LangChain as well, so must be the top stuff. All right, so today, I'm not finished yet. I have a bonus talking points as well, so don't get too excited. I wanted to give you intuition, what to look out for, like what to like on LinkedIn, what to skip, yeah, because we all can see what everyone is liking. So the best large language model, and we talk about DeepSeek. So I'm particularly interested in reinforcement learning and what it will bring next. I will look out for any new models that use RL and what will it bring out. Visual language, large language models. I will look out for reasoning VLMs. At the moment, it's a bit, there's no chain of thought. You know how, for example, reasoning models, they go through this internal process of like, hold on a second, let's retract, da 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 da. For VLMs, I haven't seen anything like that. It just looks at the photo, finds the next embedding, boom, there you go. I want something that looks at the photo and thinks, what is this house? Where is it located? How about this couple? What are they wearing? Does it look like 80s or 90s fashion? Something like that. And finally, for agents, I will look out for agents that deliver business value. Probably many corporates are playing with the agents and experimenting, but I don't think we've seen a good practical agent yet. So I will look out for practical applications. Okay, and let's address the elephant in the room that was already addressed in the keynote speech. Will AI take our jobs? This is one study that OpenAI did. They collected 1,400 real software engineering tasks from freelance platform Upwork. Total value of those tasks was about $1 million. They ranged from $50 bug fixes to $30,000 feature requests, and they unleashed models at it. Can model make $1 million from freelance work? What do you think the best model, what was the highest percentage of solved tasks? Anyone want to throw some numbers at me? From 0 to 100? 10%, good. All right, 70, 30, oh, yeah, very close. On average, we are right. So it was 47% of the tasks that it was able to solve. I don't think you'll be taking anyone's job with the Upwork profile like that. But still, nevertheless, it was able to generate $400,000 in profit. I mean, those tasks were already solved. It was after the fact. So hashtag legit side hustle. Anyone? And you know why it failed, because you tried it, right? So debugging and root cause analysis, LLMs are very fast to identify the issue, but it struggles to find the root cause. And contextual understanding. When project involves multiple files, it's hard for modern models to keep the context, and they falter when they need to do cross-file reasoning. But this is not for long. I mean, next year, I won't get away with this slide, because it won't be the case. Finally, as Andrei Karpathy has said, LLMs are like Swiss cheese. They mostly work, but then they'll randomly fail. And those random fails will become viral on LinkedIn. Do you know what I'm talking about with this 9.11 or 9.9? Yeah, for a while it was saying that 9.9 is 9.11 is greater, until I think they hard-coded this exact question in the system prompt. But a group of researchers actually looked at this question, and they identified that when you ask a question like that, the same parameters light up when you ask questions about Bible verses. So it was treating these as paragraphs, not as numbers, for whatever reason. And then another viral example is count R's in strawberry, and it was coming up with all sorts of delusional answers. Well, again, LLMs don't see letters, they see tokens. So when you pass strawberry, it's actually broken into 2 or 3 tokens, which has nothing to do with R. And by the way, solutions to both of them are just to say use code. So instead of trying to its neural net, it will write a little Python script and give you the right answer. And finally, weird examples like this reversal curse thing. Right, thank you for listening to my talk. Let's chat afterwards. I hope you enjoyed it.